Welcome to ClickMyProject.com. Now we will discuss about use an Addons system to consolidate multiple web applications in cloud environment. The infrastructure as a service cloud provides the virtual machines under pay-per-use business model, which can be used to create the dynamically scalable cluster of servers to deploy one or more web applications. In contrast to the traditional dedicated hosting of web applications, where each VM is used exclusively for one particular web application, the shared hosting of web application allows the improved VM utilization by sharing VM resources among multiple concurrent web applications. Web applications are often deployed in three-tier computer architecture, where the application server tier usually uses computer cluster to process a large number of concurrent user requests. Traditionally, these clusters composed of fixed number of computers dimensions to serve predetermined maximum number of concurrent users. However, in infrastructure as a service cloud such as Amazon Elastic Cloud currently offer computing resources such as network bandwidth, storage, and virtual machines under pay-per-use business model. This infrastructure as a service cloud enables the creation of dynamically scalable server where virtual machine can be added and removed to dynamically provide a good trade-off between cost and performance. Determining the number of virtual machine to provision for dynamically scalable cluster is an important problem. The exact number of virtual machine needed is specific time dependent upon user load and the quality of service requirements. Under provisioning leads to super service, where poor provisioning results in increased operation cost. The existing server consolidation approaches are used in data centers to minimize underutilization of physical machines and to optimize their power efficiency. The main idea is in approaches to use live VM migration to periodically consolidate VM so that some underutilized physical machines could be realized for termination. In this paper, we propose to use a similar technique to cost efficiently consolidate multiple concurrent third-party web applications in cloud-based shared hosting environment. The key difference in proposed approach in that we consolidate application on VM rather than consolidate VM on physical machine. Let us see the flow of our process. First of all, we have to initialize the number of data centers. After creating the number of data centers, we have initializing the number of virtual machines, and also we have initializing the number of brokers. Then we have initializing the number of cloudlets. After getting the cloud parameters, we have calculate the fitness value of cloudlet, and then we have applying the global blessed value of cloudlet. Then we have find outing the pheromone best. We have constructing the pheromone table. In pheromone table, we have to calculating the weight of each cloudlets. Then find the pheromone based solution. Finally, we have assigned the task based on the weight value. Let us see the demo of our process. First of all, we have to run title.java. First of all, we have to create the data center. we have to enter any number of data center. For example, we have created the number of data center 3. The 3 data centers are created. These are the data center name, number of machines, host ID, number of physical equipments, and RAM bandwidth. After that, we have to create number of brokers. We can enter number of brokers. 2 brokers created successfully. This is the broker 0, broker 1. 5 is the ID of broker ID 0. 6 is the broker ID of broker 1. After that, we have to create the virtual machine. The 4 virtual machines are created successfully. Virtual machines submitted to respective brokers successfully. The virtual machine contains the virtual machine ID, broker ID, MIPS, and RAM bandwidth. After that, we have to create the cloudlet. For example, we have to create 5 cloudlet. The 5 cloudlets created successfully. Cloudlets submitted to respective brokers successfully. After that, we have to compute the load. In load computation, we have getting the unique ID, bandwidth, RAM, and MIPS, and number of physical equipments. The total load of virtual machine is 9504, and the total load of virtual machine 1 is 8603. After that, we have to compute the demand. In demand, we have getting the file size and output size. After that, we have to calculate the total demand of cloudlets. For example, 26005 219324. After that, we have to optimize the resource. This is the broker ID 0. Optimized load is 9504. Broker ID 5 is 838603. After that, we have to click demand retain. In demand ranking, we have to getting the optimized demand. After that, we have to create the network topology. Network topology execution. In final network topology execution, we are getting the cloudlet ID 0, 1, 3, 2, 4, and data center ID. The cloudlet should be allocated to data center 5. The cloudlet 1 should be allocated to data center 5. Cloudlet 3 is 5. The cloudlet 2 should be allocated to data center 6. Cloudlet 4 should be allocated to data center 6. The these are the length of the cloudlets. Thank you.